How tantalizing is the prospect of predicting earthquakes in advance? A question that has puzzled scientists for centuries might be on the cusp of a breakthrough, thanks to a team of German scientists. Their new research suggests that we could track major earthquakes months or even years before they strike by detecting unique seismic signals. These scientists have delved deep into the heart of our planet, studying the data related to the Kahramanmaraş earthquake that hit Turkey in early 2023. They found an acceleration in seismic event rates and larger energy release approximately 8 months before the tremor. This discovery could be a game changer in predicting when and where the next big earthquake might hit. The seismic signals were detected in clusters within 40 miles of the epicenter. Interestingly, these signals were detected on both main and secondary faults, areas which previously hadn't been the focus of much scientific attention. The primary rupture occurred on a fault line in an area known to be at risk of earthquakes, but the signals prior to the event were detected in these secondary faults as well. These discoveries suggest a preparation phase for larger earthquakes, during which these identifiable signals may be detected. However, the researchers caution that such monitoring is challenging due to the multitude of variables that must be observed simultaneously. The implications of this research are immense. Currently, short-term prediction of earthquake magnitude, time, and location is impossible. But these German scientists argue that long-term monitoring is crucial to build our understanding of earthquakes and predict future events. However, not everyone in the scientific community shares the same enthusiasm. Bill McGuire, professor of geophysical and climate hazards at UCL, suggests that while this research is interesting from a scientific viewpoint, knowing a big earthquake might be on the way within months or years doesn't really advance our preparedness for them. Professor McGuire posits that the only truly useful prediction of future seismic activity is the one that accurately pinpoints the location of a coming quake and its timing to within a few weeks, enough to allow evacuation. In terms of reducing the impacts of a future quake, knowing one is on the way within months to years wouldn't provide us with the time we would need to retrofit poorly constructed buildings. In a nutshell, this research opens up a new frontier in earthquake prediction. It advocates for more local and regional sites to detect underground signals and stresses the importance of monitoring secondary faults after a primary fault ruptures. However, it also highlights the complexity of predicting earthquakes, with many variables to observe, and the challenges in translating this knowledge into practical disaster preparedness. This is a fascinating field of study, one that holds the potential to save lives and significantly reduce the damage caused by these devastating natural disasters. But as with all scientific discoveries, it's a stepping stone, a part of the larger puzzle that we are yet to fully comprehend.